In this video we're going to look at resultant of forces. So the resultant of a force is the single force which replaces all of the forces. So it is equivalent to just all of the forces being reduced to just one single force. The direction of this force is very important, and so this resultant force has got size, which is the size of the force in newtons, and also direction. And the direction you normally give compared to the horizontal or the vertical. Okay, we're going to look at a couple of examples here. In this first example, it says replace the forces shown below with a single resultant force, calculate the magnitude, so the magnitude just means the size of the resultant, and calculate the angle the resultant makes with a horizontal where appropriate. So in part A, and how we like to set this out is we like to just say resolve horizontally, and the wee arrows pointing to the right, which means anything going to the right I'm going to take as positive. So if you think what I have going to the right, I have got 15 newtons going to the right. Going against that, trying to stop that, I suppose you could say, is a 10. So you have 15 minus 10, which is just going to be equal to 5 newtons. It's going horizontal, so there's nothing else that you need to do. So your answer is just 15, becomes 15 minus 10, so it is just 5 newtons. Our second example here, part B, a wee bit different. What we have here is we've got two forces which are acting perpendicular, so they're acting at right angles to each other. So what we're going to do is redraw this. So you may remember, if we look back at our vectors notes, we may remember we talked about the nose to tail method for adding vectors. It is the same idea here. So where one force finishes, we're going to start the next one. So I'm going to draw this horizontally. First I'm going to go, I have my 7 newtons going this way. And then after that, where it finishes, which is over here, I'm going to draw my 2 newtons, which is going up like this. So it is 2 newtons going up this way. So what my resultant is, remember, it's a single force which can replace those. So a single force is going to start here and it's going to finish here. So we're going to call this R for resultant, and we can find R. Now we have got, very important, mark this is a right angle. So it's a right angle triangle, so you can find R using Pythagoras' theorem, and also you can find the angle with the horizontal by just using your simple trig, SOHCAHTOA, to find theta. So we will do that over here. So R, first of all, is equal to the square root of 7 squared, just put that in bracket please, 7 squared plus 2 squared, and if you do that in your calculator, that's going to be 49 plus 4. 49 plus 4 is going to be 53, and it's the square root of 53 newtons. I haven't given that to any decimal places. That square root of 53 is a perfect answer, but just to give it to a couple of decimal places, which is 7.28 newtons to 2 dp's. Same idea to find your other side, to find your angle. Just going to mark on that this is my adjacent, this is my opposite. So we'll just write down our SOHCAHTOA, and it's going to be tan, because tan theta is equal to opposite over adjacent, which means tan of theta is equal to 2 over 7, and then just do that in your calculator. Tan to the minus 1 of 2 divided by 7, press equals, and what I have got for my theta is 15.9 degrees, and I've gone to 1 decimal place, and that's it. In this example, we could have drawn our triangle a different way. So we could have started with our 2 going up, and then gone horizontally and done your 7 going across, and your R would be the same. So if you calculate your R, still a right angle triangle, R would be equal to the square root of 2 squared plus 7 squared. Your theta, you would have to be in here, and again it would work out to the same angle. So just to show you that you could have drawn your triangle a different way, but generally it's easier to do a horizontal line across. Generally they want the angle with the horizontal. Okay, in part C, so again they want the angle with the horizontal, so we're just going to do the horizontal first. We're going to redraw again. Just say redraw. you've got 5 going this way, and then you've your 12 going down. So where 1 finishes, the 5 finishes here, so 12 starts here, and overall it finishes here. So your R is a single force which replaces them, and we want our theta to be here because we want the angle between the horizontal. Okay, so R is dead easy to find. R is just going to be equal to the square root of 5 squared plus 12 squared, and that works out really nicely because that's what's called a Pythagorean triple, so it's 13 newtons. And we're going to use tan again. Tan is equal to the 12 over 5 this time. So theta is equal to, I'll show a wee bit more working out this time, tan to the minus 1 of 12 over 5. So theta works out to be, and then if we do that, I'll just check that on our calculators, tan to the minus 1 of 12 divided by 5, press equals, and what I've gone to 2 decimal places this time, I've gone 67.38 degrees, and that's to 2 dPs. Okay, our last example for this video, it says a rectangle of forces shown below, calculate the magnitude and direction of the resultant. So we cannot use exactly the same method as the last one because we've got more than 2 forces acting here, so we've got 4 forces. But what we can do is we can look at this thing and find out, well, what is the overall horizontal force, what is the overall vertical force, and then we basically will have the same situation as the last time. So we find the overall horizontal force. I don't know what it is, so maybe we found out it was 20 newtons this way, and maybe we find the overall vertical force was 10 newtons this way. Then you could redraw that as 20 and then a 10, and then it's exactly the same question as before. Okay, but we'll have to find the horizontal and vertical forces first before we do that, so we'll do this properly. Okay, we'll just get rid of all that and then we will get started. Okay, first thing then we want to do is resolve horizontally. So I'm going to resolve, I can see if I have a look at this, the 17.5 newtons is bigger than the 13.5. So I'm going to take the direction of the 17.5 going as positive. So I'm going to resolve horizontally, but anything going to the left is positive. So what I have is 17.5 minus 13. And 17.5 minus 13 is going to be 4.5 newtons. Same idea going vertically. I can see I'm going to resolve vertically downwards because I've got 4 going downwards and I've got 2 going up. So that's just going to be 2 going downwards. So after I've done all this, what I'm going to do is redraw. So this whole system of 4 forces just becomes 2 single forces. It becomes 4.5 newtons going left. After that, it becomes 2 newtons going down. So the single force which replaces those is called R. Do a right angle and also mark in theta. So the question is just like before, and all we have to do is find your R and find theta. So R, first of all, is the square root of the 2 squared plus the 4.5 squared. Do that on your calculator, please. And I'm just going to do that again just to check. So square root of 2 squared plus 4.5 squared, press equals, and it comes up as root 97 over 2, which is not a very nice surge, so we'll write that as 4.92 newtons, and that's to 2 decimal places. Same idea, your tan theta is equal to 2 over 4.5, which means theta is equal to tan to the minus 1 of 2 over 4.5, which means theta works out to be, again let's just check that, tan to the minus 1 of 2 divided by 4.5, which is equal to 23.96 degrees to 2 decimal places. Okay, so we now know how to find the resultant of forces, which are either all horizontal or else they're in perpendicular direction. So this could be extended to any number of horizontal and vertical forces. So if you had 100 forces going vertically, you could find their overall resultant vertically, and also at the same time you've got 100 forces going horizontally. You could find their overall horizontal component, and then what you could do is just combine them, redraw it. It's just two forces. The 4 point, in this example, 4.5 going horizontally, 2 going vertically. So 4.5 to the left it was in this case, 2 going down. You can find your R using Pythagoras, and you can find your theta and put it to the horizontal, and then that is it. You found your theta using your SOHCAHTOA.